that you have. I think there's an announcement that some exam notes that I would like to share to you. So the exam or the quiz will be open at 8 a.m. on May 28th until 11:59 of May 30. I think that's enough time for you to do it. So the quiz will be in a Google form quiz and time by Quilgo. Okay, you will receive the link to the quiz on May 28th. And you have 150 minutes to answer the questions there. So you have to prepare your calculator kasi may calculation problem. Okay, but you don't have to attach any file for this quiz. And then sabi dito, refrain from going back to previous question. If you need to do so, do not change your answers in the non-graded question so that the same set will be given to you and will not cause unnecessary panic. Should there be a problem, let me know. So we have a different time zone. Please use my email, emojica@pace.edu. Okay, emojica@pace.edu. Once I read it, I will reply to you right away. Okay? And if you already submitted your form, but the timer still runs, the Quilgo still runs, it's okay as long as you receive some sort of a message your response has been submitted, that your quiz is recorded. Okay? Handa na ba kayo? So what we're going to do today is just to continue the electrochemistry part. So we started already with the redox last time. So meron tayong tinatawag na oxidation number, right? So we say we need to know the concept of oxidation number because that's the only way for us to determine if we have a redox reaction. So usually a redox reaction will have elements whose oxidation number will change. Either they will undergo loss of electron or they will gain electron. So if you're going to recall, I asked you for this one, Leora and Jaroa. You still know the meaning of that? Okay. So kapag sinabi nating Leora, so that's loose electron. Which undergo oxidation. And that is your reducing agent. Now kapag Jaroa naman, that's gain electron, which undergo reduction, oxidizing agent. So I think if you remember them, it's easy for you to know what happened to the element. But the only way for you to determine if one oxidized or reduced is to see if there's a change in the oxidation number. So usually, what's the change in the oxidation number? The one that oxidized becomes more positive, and the one that's reduced becomes more negative. Why does it becomes more positive? Because you lose electron. It becomes more negative because it gains electron, since electron has a negative sign. So are we clear on that? So what I'll ask you to do is I'm going to solve a problem from your SAQ. I'm not going to use this one, but I have a recorded solution for this in my lecture in one of the links. So if you want to see how this is being solved, you can always go there. So the one that I'm going to use is the one that we have in your self-assessment question. Okay, so the one that you have there is this copper plus H plus NO3 producing copper 2 plus NO2 plus H2O. So what's the first thing that we're going to do? Ay, magrigodon kayo tatlo? Tawagan ko? Ano muna natin gagawin? Ang una natin gagawin ay
Oxidation number po. Alam oxidation number. Yung oxidation number po.
Assign natin yung oxidation number. So, ano oxidation number ng copper metal dito?
0.
0. This one, whatever the charge, plus 1. This one, whatever the charge, plus 2. And then hydrogen is always plus 1, and this is negative 2. So this is negative 2, this is negative 2. So ano yung oxidation number ng nitrogen dito at ng nitrogen dito? So unahin natin yung nitrogen sa reactant. Anyone? So lahat ito zero charge. So ang gawin natin, i-add lang kung ano yung mga oxidation number times the number of the elements. So this is negative 2 times 3 giving you?
Negative 6.
Negative 6 plus the oxidation number of nitrogen will give you 0. So that will give you positive?
Positive 6.
6. And this one?
Positive 4.
Positive 4. Very good. So, alin yung na-oxidize at alin yung na-reduce? So when you say OHR, oxidation half reaction, RHR, reduction half reaction. So alin dito ang na-oxidize? Anyone? Eric, John, Dale? So we could say this is the one that oxidized. And this is the one that's reduced. Now, ang tanong ngayon, alin yung reducing agent, alin yung oxidizing agent? Pwede mahula. Walang masamang mahula. At least ngayon. Mahirap manghula kapag squeeze na. So ano sa tingin niyo yung reducing agent?
Copper.
Copper. At yung oxidizing agent ay?
NO.
NO3. Now, one way to know if you are a reducing agent, usually most of the reducing agent are the metals. And most of the oxidizing agent is, from the word oxidizing, the one that contains oxygen. Okay? Now, as you could see here, oxygen was what? Reduced. Because it's responsible for oxidizing another reagent. So, the next thing that we're going to do is to balance them by half reaction method. So, balance na yung copper, pero yung charge dito ay plus 2, dito ay 0, so magdadagdag ka ng 2 electrons. Any question on that? Bakit 2? Okay. Now this one, nitrogen is 1, oxygen is 3, oxygen is 2, and as you could see in the reaction, there's a water that you have there. So when you add it, meron kang tatlong oxygen pero nadagdagan yung nitrogen mo. So i-expand ko lang dito kasi magdadagdag ka ng 2H plus to balance the hydrogen from the water here. And since you have a positive 2 on this side and no charge here, magdadagdag ka ng negative 2. So when that happen, balance na yun, exchange ng electron, and all you need to do is add everything. And what you're going to do, check both sides in terms of the reagents. Copper, copper, dalawa, tig-isa sila, 2 hydrogen from H2O, 1N, 1N, 3 oxygen here, 2 here, plus 1, 3. And then in charge, plus 2 on this side, plus 2 on the other side, balance. So you could say this is what? Acidic or basic solution? Anyone?
Acidic po. Since
Acidic.
may ano po, presence po ng H+.
Okay. Now what if we're going to make it basic? What will we do? Anong gagawin mo? Anong gagawin natin kapag gusto natin sa basic yan?
Magdadagdag po nung OH.
Ilang OH?
Kung gaano po karami yung hydrogen plus.
Okay. So since meron kang dalawang H plus doon, magdadagdag ka ng dalawang hydroxide both sides. And this one becomes 2H2O. And since you have an H2O here, so this now becomes 1H2O. And then the next thing that we're going to do, make sure you have the same number of elements on both sides. 1 copper, 1N, 1N, 3 oxygen plus 1, that's 4. Okay, so that means you have 2 here plus 2 here, that's 4. And then 2 hydrogen, 2 times 1 there, you have 2 hydrogen. In terms of charge, wala na to. So you have nothing on this side. So you have here plus 2 and 2 times negative 1, 0. So you have there now the balance redox equation. Tanong. Huwag kayong mahiya. Tanong. May tanong? Anyone has a question? Because we will leave this part now and go to cells. So let's go now to electrochemical cell. So electrochemical cell, that's the product of redox. That's the product of electrochemistry. Ang basis ng electrochemistry is redox reaction, electron transfer. And one of the products of this is the electrochemical cells. So there are two types of electrochemical cells. Now, when we're talking about electrochemical cells, so usually it's a system that contains an electrode, which is usually a metal that is dipped into an electrolyte and in which a chemical reaction either uses or generates an electric current. So you have a cell that use or produce energy. So the first type of electrochemical cell is what we call the voltaic cell or the galvanic cell. It's an electrochemical cell in which a spontaneous reaction generates an electric current. Are you familiar with the concept spontaneous? Yung totoo.
Yung spontaneous po ba yung ano, tuloy-tuloy?
Tuloy-tuloy? Hindi naman masyadong tuloy-tuloy. Tinakil nyo ba to earlier dito sa course na to? Sorry. Get away, get away. Okay. Pag sinabi natin spontaneous, ito yung nangyayari on its own. No outside intervention. Okay? Spontaneous process. Gaya nito, kapag binitawan ko tong writing pen ko, spontaneously, ano mangyayari? Mahuhulog. Right? Now, unless meron akong force, okay, the only way na bumalik siya is outside intervention. Kung may force ako, pwede kong yan na ganun, babalik sa kamay mo yung pen, pero hindi mangyayari yun. Yun yung spontaneous. Okay? So whatever you have here will spontaneously go down. Another classic example that we use about spontaneous na sinasabi ko sa mga estudyante ko around the world, failing an exam. Ano sa tingin niyo mangyayari sa inyo kapag hindi kayo nag-aral para sa quiz ninyo this week? Spontaneously, you will what? Fail the test. Wala kayong gagawin. Hindi kayo mag-aaral. Hindi kayo mag-prepare. Hindi kayo magbabasa. So spontaneously, most likely, you will not pass the test. So spontaneous reaction happen on its own without outside intervention. Yun yung voltaic cell or galvanic cell. Anong classic example ng voltaic cell or galvanic cell? Anyone? Battery is a voltaic or galvanic cell. And the name voltaic and galvanic is based on surnames of scientists who work on electrochem, Alessandro Volta and Luigi Galvani. Now, electrolytic cell, on the other hand, this is an electrochemical cell in which you use energy to drive an otherwise non-spontaneous reaction. So, yun yung pagkakaiba. But, yung design nila pareho. Meron kang electrode na nakadip sa electrolyte. Yung direction ng electron nila, it's from one electrode to another that we're going to discuss today. Okay? So for instance, when you have an electrochemical cell, they said you have ABC. This is the anode, this is the cathode, and this is the salt bridge. Your electrons always travel from the anode to the cathode, or you could say alphabetically. Okay? So, mangyari yan, kapag spontaneous yung reaction, yung anode mo, mag-produce ng electron papunta doon sa cathode, and at the same time, you have energy. Now, kapag electrolytic cell ka, you're going to apply energy para mag-run yung reaction. Okay? Now, in the anode, this is an electrode where what? Oxidation takes place. The cathode, on the other hand, that's the electrode at which reduction takes place. This is irregardless whether you have a galvanic cell or an electrolytic cell. Paano mo malalaman to? Vowel to vowel, consonant to consonant. And as you could see here, electrons flow through the external circuit from the anode to the cathode. So if that happened, okay, we could say electrons travel from A to C. So what happened to the electrolyte here? Ano yung charge na magpo-form dyan kapag napunta yung electron? Positive or negative? Anyone?
Positive po.
Positive? Anong charge ng electron? So since negative yung napunta dyan, negative charge siya. Now, ano naman yung magiging charge dito kapag umalis yung electron sa electrolyte dito? doon siya magiging positive. So convinced na since nandito papunta yung electron, yung solution dito ay negative charge. Convinced kayo doon? Okay? And since dito umalis yung electron, nandyan yung positive charge. However, hindi pwedeng ganyan yung voltaic cell. Diyan papasok yung role ng salt bridge. So yung salt bridge is a tube of electrolyte in a gel that's connected to the two half cells of the voltaic cell. And it allows the flow of ions but prevents the mixing of different solutions that would direct reactions of the cell reactants. What it do, the cations move toward the cathode and the anions move toward the anode. The main role of the salt bridge is to maintain neutrality or electron neutrality. So ano ibig sabihin nito? Hindi ka pwedeng magkaroon ng positive charge dito at negative charge dito. So ano mangyayari? Ano nasa salt bridge? Anyone? Meron kang salt. Kaya nga tinawag na salt bridge eh. So what the salt do is, when you put it in a solution, it will dissociate to give you a positive and a negative ion. So since you have a negative ions here, a negative charge here, pupunta dyan sa cathode yung cation. And since you have a positive charge here in your anode, pupunta dyan yung anion. Now in doing that, you're going to have a neutral charge on both half cell reaction. Nakuha ba? Nakuha yung explanation ko? So ang main role ng salt bridge is to maintain the electron neutrality. Ayaw mo yung isang half cell reaction different yung charge doon sa isa pa. So kung saan napupunta yung electron na nagiging negative charge, which is your cathode, pupunta doon yung cations ng salt bridge. Yung anode mo naman, na kung saan, okay, you lost the electron, nagiging positive, pupunta doon yung anions ng yung salt bridge. Okay? Now, the next question that you have is what? Sir, bakit po ito nandito at ito nandito? Bakit sinasabi natin dito na yung zinc electrode ay yung anode at yung copper electrode ay yung cathode? Anong kwento dyan? Okay? What's the story there? Well, in a galvanic cell, as you could see, anode going to cathode in terms of the electron traveling in an external circuit. So if you're going to look at this, this is your anode, this is the cathode, this is the salt bridge. So yung nakukuha nila dito yung tinatawag natin either as cell voltage, electromotive force, or cell potential. Yan yung energy na na-produce. Kaya ginagamit natin to as what? Battery. Okay? Now, this is the overall reaction. If you're going to identify here which one was oxidized and which one was reduced. Anyone? Jan? Eric? Dale? Ano yung na-oxidize dito?
Sir, zinc yung na-oxidize tapos copper yung na-reduce.
Ha?
Sir, zinc yung na-oxidize tapos copper yung na-reduce.
Okay, very good. So kapag tinignan natin yung oxidation half reaction dito, you have zinc producing zinc 2 plus 2 electrons. And then copper 2 plus reacting with two electrons to produce copper. So if you're going to look at this, kapag in-add mo sila, ito yung overall equation. Now, you can also write it in terms of what we call the cell diagram. You can put the concentration of the electrolytes that you have, which in this case are all about 1 molar. So when you have a cell diagram, this is a shorthand notation, okay, in writing a galvanic or voltaic cell. So usually it's alphabetically from A to C. So you put the reaction there, zinc reactant, zinc 2 plus, and then a bar line here that denotes different phase boundary. Kasi yung isa metal, yung isa solution. Okay, so you put here the anode. Now you have a double bar here that denotes your salt bridge. And then on this side, tingnan nyo, kung ano yung nasa reactant dito sa reduction half reaction, yun yung mauuna and its concentration. And then you have the copper. But again, you still beg to ask the question, why is the zinc the anode? And why is the copper the cathode? Right? Now, this has something to do with the so-called reduction potential. Okay, so what did they do? So they prepare and determine, they prepare different metals with the respective electrolytes and then determine the reduction potential by matching them in the so-called hydrogen electrode. So anong ginawa nila? So meron kang different metal, zinc here, in zinc 2 plus, deep in zinc 2 plus, meron kang Fe, deep in Fe2 plus or Fe3 plus, and so on. And what they do, okay, they match it with the so-called hydrogen electrode. Now you might ask, why hydrogen electrode? They set it as the standard. Ang tawag dyan is SHE, standard hydrogen electrode. Now, when they match zinc electrode with the hydrogen electrode, this is the cell notation that came out. So the question here, okay, why is the zinc the anode and why is the hydrogen the cathode? Well, based on the cell notation, we could say here, zinc is the one that is written as the anode and hydrogen is the cathode. Or based on the figure, usually the one that is on the left, that's your what? The anode, and the one that's on your right, that's the cathode. Okay, but there's still more issues on that. Okay, but before we go on, let's talk about, so this is the overall reaction. But before we go on to determine, okay, the cell potential, let's talk about the SHE. Okay, so the standard reduction potential, that's the voltage associated with a reduction reaction at an electrode when all solutes are 1 molar and all gases are 1 atmosphere. So they chosen hydrogen as the standard hydrogen electrode or the standard electrode. So what does it mean? They set it as the point of comparison. So lahat ng ibang metal electrode deep in their respective electrolyte, imamatch nila dito sa electrode na to. And to simplify, okay, they assign a reduction potential that is equals to 0 volt. Why 0? Sa tingin nyo, bakit 0? They assign the number 0 because this reaction can always be reversible, giving you instead this one. So if this reaction is now reversed, what do you think is the value of your standard potential? Anyone? Pag ni-reverse ko tong reaction na to, ano na ngayon yung reading dito?
Negative po. May
Negative?
negative.
Ha? Zero siya. So pag ni-reverse mo ng reaction, zero pa rin siya. Okay? Hindi magpapalit yung sign kapag ang value mo ay zero. So whoever designed this one was wise enough, smart enough to put this. Because, okay, he or she deduced that some of the metal might have a much higher reduction potential than hydrogen electrode. And some of the metal might have lower reduction potential in comparison to the hydrogen electrode. So knowing this stuff, we go back to the zinc and the hydrogen electrode. Okay, so as we could say, there are two electrodes, and we can assign that as what? Cathode and anode. And usually, to get the cell potential, you can use this formula. E cell equals to E cathode minus E anode. Okay? So if this is the cell diagram, alin dito ang may value na? At alin dito yung kukunin natin yung value? Anyone? I want you to participate. Maghula lang kayo, okay lang.
Sir, yung standard EMF po ng anode,
Ha?
yung anode po, meron na pong value na 0.
Okay. So we will assign this as 0. Is it really the 0? Tindaan nyo, alin dito yung anode? Ang anode ba ang 0 o yung cathode?
Yung cathode po pala.
Okay? Kasi ito yung anode, di ba? Tapos ito yung cathode. So usually, ito yung alam na natin. Ito yung inaalam natin. Kasi meron tayong 0.76, di ba? So, hindi natin alam yung reduction potential nito. Pero alam natin, wait, mali ata ako. Okay, so 0.76 equals to 0, tapos ito dito. So ano ngayon yung value nito? Kasi ito na yung reduction potential kapag meron kang zinc 2 plus 2 electrons, you produce that one. So if this is values like this one, so how are we going to assign this?
Combine similar terms.
0 minus 0.76 ba?
Yes po.
So that will give us
Negative 0.76.
so ito yung value ng reduction potential ng zinc. Now, what if ang minatch naman natin sa electrode ay yung copper? Like this one. Now, sa tingin niyo, ano nangyari? Compared to zinc, ito yung cell notation niya. I'm going to write it. Tignan ko lang muna dito. Nope. Mali yung cell notation ko. So ito yung cell notation niya, not H2, we have platinum, H2, which is 1 atmosphere, and then you have H plus, which is 1 molar, and then you have double line, you have copper 2 plus, and you have copper. So ano masasabi ninyo? Ano nangyari sa anode? Ano nangyari sa cathode? So alin dito yung anode? Yung hydrogen o yung copper? Based sa cell notation.
Yung hydrogen po yung anode.
Okay? So yung hydrogen yung anode. So we can put the reaction like this one, H2 producing 2H plus times 2 electrodes. And the other one is copper 2 plus 2 electrodes, copper. So again, alin dito ang meron ng value at alin dito yung aalamin natin. Kasi ang inaalam natin dito ay yung reduction potential nito. We want to know what's the reduction potential of copper. So we have 0.34 here. So nasa alin yung zero dyan? Yung cathode or yung anode?
Sir.
Anyone?
So yung anode yung 0.
Okay, very good. So this one would be like this. And this one is 0. So if this is 0, so we could say yung reduction potential niya ay 0.34. So what can you say? So you have here what? 0.34 versus 0. And here you have negative 0.76 versus 0. Right? So anong masasay ninyo? Yung cathode usually mas mataas yung value or mas mababa? So you have 0 versus negative 0.76 for this one, and then you have 0.34 versus 0. So usually, mapapansin niyo yung more positive siya yung cathode, yung more negative siya yung anode. Gets nyo? Kasi yan yung basis nung tinatawag nating reduction potential. Okay? If we're going to look at this reduction potential, sabi ko nga sa inyo, yung reduction potential is for what? The reduction reaction as written here. And usually, the more positive the potential, the greater the tendency for the substance to reduce. So ano yung nasa cathode? Usually, mas malaki yung value nila, di ba? Compared dun sa anode. Kasi yung cathode yung reduction, yung anode yung oxidation. Reversible yung half cell reaction. But for simplicity, hindi natin gagamitin yung concept na to. Okay? Mag-stick tayo doon sa E cell equals to the potential in the cathode and minus the potential in the anode. We can change the sign of the cell potential when we reverse the reaction, but I have told you the simplest thing that I always ask my students to avoid confusion, use what it is in the table. All you need to know is what is the cathode and what is the anode. We will have some example on that, so don't worry. And last but not the least, changing the stoichiometric coefficients of a half cell reaction does not change the cell potential value. So i-multiply mo man siya, yung cell potential mo hindi magbabago. In short, the cell potential is an internal property. Okay? So let's look at this, the one that we have. So we have this compared to this one, right? And then we have this one. So between zinc and hydrogen, this is what? This is the anode, this is the cathode, right? Tama ba? Now between copper and H, this is the anode, this is the cathode. Now what happened if we compare this with this one? Alin yung cathode, alin yung anode? Zinc and copper.
Yung copper po yung cathode.
Okay? So yung copper yung cathode, ito yung anode. So yan na yung explanation ngayon. Earlier, bakit yung zinc ay yung anode, bakit yung copper ay yung cathode. Now, the next thing that we could say, okay, ano yung cell potential ng dalawa? So we can solve it. Okay, go on.
Magiging copper minus zinc po.
Copper minus zinc. Very good. So you have E cathode minus E anode. Ang direction ko nga dito sa mga estudyante ko, kung ano yung nasa table, gamitin yung value. Kasi, di ba, may statement doon na ito ma-oxidize. So kapag mag-oxidize ito, magiging ano na siya, oxidation potential. Hindi na siya reduction potential. But for simplicity, I would just suggest use the reduction potential. All you need to do is identify which is the cathode and which is the anode. But the value that you're going to plug in is the reduction potential. When we say reduction potential, kung ano yung nakalista dito. Kasi yung iba nako-confuse eh. So, ang ginagawa ko, kung confused sila, gamitin nila itong formula. So, anong ibig sabihin to? So, isulat nila kung ano yung reduction potential ng cathode at ano yung ngayon yung oxidation potential ng anode. So, in this case, you will have what? 0.34 plus, ano na mangyayari nito pag nag-oxidation potential? Ano yung sagot mo in both calculation? Anyone? Ano yung sagot dito kapag ginawa mo yung operation? Ano yung sagot dito kapag ginawa mo yung operation?
Parehas pong positive 1.1.
Pareho silang positive 1.1. So I leave it up to you kung ano yung gagawin nyo. But as I've told you, I find this more simple. All you need to do is just assign, if ever this is a voltaic cell, assign the higher or more positive value to the cathode and the more negative value to the anode as is. Okay? So let's try more. Anong mangyayari kapag meron kang bromine liquid, in-add mo sa merong NaCl and NaI? Assume all species are there in standard size. So ano ngayon yung mga species na meron ka? Meron kang Br2, meron kang Cl-, meron kang I-. Okay? So the next thing that you're going to do is you need to look at the thing here. So anong gagawin mo? Wala ata yung chlorine dito. So we can go on the one here. So the chlorine is where? Medyo malabo. I think this one. The bromine is here. And the iodine is here. So paano natin i-interpret yan? Wala akong paano natin interpret yan? So, sulat natin lahat. Br2 plus 2 electron Cl2 plus 2 electron 2Cl minus I2 plus 2 electron 2I minus. And the next thing that we're going to do is yung reduction potential nila. So you have what? 1.36, 1.07, oops, ito yung 1.07, ito yung 1.36, and the other one is 0.53. So ano mangyayari? Analyze. Alin yung maapektuhan ng bromine at alin yung hindi maapektuhan. So ang gagawin mo, i-pair up mo yan sila. Itong dalawa versus ditong dalawa. So between bromine and chlorine, alin yung magre-reduce, alin yung mag-oxidize? Ano yung species meron tayo? Ito, ito, at ito. So ibig sabihin, ito ay dapat nasa reactant side. Mag-oxidize ba ito compared doon? Yes or no? Anyone? John? Eric? Dale?
Wait lang po, sir. Ina-analyze pa.
Ha?
Tingnan pa.
Yan yung value. Compare nyo. Between dito sa value na to, alin yung mag-oxidize, alin yung magre-reduce?
Sir, yung Cl po yung magre-reduce?
Hindi. Dapat ito nandoon sa reactant. Kasi reduction form lahat to eh. Kaya ang tanong, pwede ba ito mapunta doon sa reactant kung i-compare mo to compare dito? Ganon din sa iodide. Ito dapat nasa reactant kasi ang present nga ng species itong tatlo. So most likely ano? Itong dalawa or itong dalawa ang mag-perform, ang magre-react. So ang hanapin mo, ano yung ano natin sa reduction potential? Kung ano yung more positive, siya ang alin?
Cathode.
Siya yung magre-reduce, siya yung cathode. Now, pwede ba maging cathode ang bromine kapag minix mo siya sa chloride based on the numbers here? The answer is no. Because between the two, ito yung marireduce, ito yung ma-oxidize based on the number. So this won't happen. But this one can happen because you have 107 compared to 0.53. So ano mangyayari dito? So ito, magiging ganito, and this will react with the bromine to give you 2Br minus. So kapag inano mo yan, you have 2 iodide reacting with bromine to give you iodine and 2 bromine. Analyze. Convince yung sarili nyo na ito yung mangyayari. At bakit yan yung mangyayari? Kasi kapag kinumpare nyo yung reduction potential, mas mataas ito. Ibig sabihin, magre-reduce yung bromine. At since mababa ito, ma-oxidize yung iodide. Convinced? Meron pa tayong isang sample. Kung hindi pa kayo convinced. Ito. You have a magnesium metal in magnesium ion solution and a silver metal in a silver ion solution. So this is still a voltaic cell. Now you are asked to calculate the cell potential. So anong kailangan natin gawin? So i-write natin yung reduction reaction ng dalawa. And then you write the reduction potential. Again, we need the table. So do we have silver here? Silver and magnesium. I can see magnesium. Do we have silver? Okay, you have here 0.80. And here you have negative 2.38. Okay, let me know which will happen in the anode and which will happen in the cathode. O yung tinatawag nating OHR at RHR. Analyze. Tingnan ko lang kung naintindihan nyo. At least dapat magsagot kayo. So ano yung ma-oxidize? Ano yung ma-reduce?
Yung magnesium po yung ma-oxidize.
Magnesium mag-oxidize. So siya yung nasa
Anode.
anode. And when you write it there, you do it in the oxidation reaction. Nagets nung iba kung bakit ito? Kasi mas mababa siya in terms of reduction potential. And that makes this as the other one. Now, the question now is, how are we going to answer the question? Paano natin ilalagay yung number dito?
Sir, yung ano po, yung magnesium po magiging positive.
You want to go that route? Kasi
Magiging
kapag naging positive to, ganito yung dapat nating formula. So if that's the case, ganito yung mangyayari. So the other way is what? So I want you to convince na pareho lang yan dalawa. Pero sabi ko nga, I don't know. Okay? Whatever you prefer, as long as you understand what you're doing. In the first equation here, what I did is I get both the reduction potential. Pag sinabi natin reduction potential, kung ano yung nasa table. And all we need to do is what? Identify which is the cathode and which is the anode. And then use whatever value that we have there. Now the second one, okay, we identify the one in the cathode and use whatever is in the reduction form and add it with the potential in the anode. But in this case, this is already what? The oxidation potential. Hindi ko kayo, hahayaan ko kayo ano yung piliin nyo because they will give you the same answer. Right? As long as naintindihan nyo kung gagawin nyo yung reverse sign nung isa. So ano sagot in both calculation? Anyone?
3.18.
3.18. Now, nagets nyo ba kung ito ang gagamitin nyo, yung value dito sa dalawa, lalo na sa anode, as is doon sa reduction potential table. But if you're going to use this one, make sure you're adding the cell potential or the reduction potential, you add it with the oxidation potential. And the oxidation potential is just what? The negative of your reduction potential. Klaro ba yun? Laging nalilito ang mga student ko dyan. So, minsan hindi ko na to dinidiscuss. And the last part that we have for today is yung spontaneity of the reaction. So, I already told you about the concept of spontaneous. Now, usually, as I have told you, yung voltaic cell natin, spontaneous yan. Okay? So, ano ibig sabihin pag spontaneous? Have you heard the word delta G, which is what? The Gibbs free energy. So, in thermodynamics, you have delta H, which is enthalpy, delta S, which is entropy. Delta H will tell you whether you have an endo or exothermic reaction. Delta S will tell you if you have what? More ordered or more disordered system. Now, delta G, what does the delta G tells you? It tells you the spontaneity of the reaction. What does it mean? It will tell you if the reaction will be spontaneous or its reverse reaction will be the one that is spontaneous. Ano ibig sabihin pag delta G is negative? Is it spontaneous or non-spontaneous? Anyone?
Sir, spontaneous pa rin.
Okay. So if it's negative, the reaction is spontaneous as written. If it's positive, the reaction is non-spontaneous as written, but spontaneous in the reverse reaction. Okay? You can write it as standard free energy, which means a standard condition, or non-standard state or condition. The other information that you have here, N is equal to the number of moles of electrons in the reaction. F is the so-called Faraday constant. So, ang relationship ng delta G sa cell potential, usually this is negative, this value is positive. Now, you can also relate your delta G there with respect to K. Ano sa tingin niyo yung relationship niya? Sa manuluya. Ginger ako kasi nagsusort throat ako pag gising sa umaga eh. Magkasunod na klase. So another one to relate delta G is also with K. Okay? And the relationship that you have, negative delta G, what do you think the K value will be? More than 1. Why? If the negative delta G is spontaneous reaction, that means the reaction happened as written. So the forward reaction is favored. If the forward reaction is favored, you have more products compared to your reactant. Hence, the K is more than 1. Now, if you combine them, you can now relate the cell potential with the K value. And you can simplify it further because you have the gas constant, standard temperature, and the Michael Faraday's number or Faraday constant. The one that's changing is just the N, which is the number of moles of electron. So if you simplify them, you can have either this value or this value. They're both the same. This is the only one where they differ and the number. Pero pareho lang sila kapag nag-calculate ka. Okay? Now, if you're going to relate the three, I think this is the summary for that. So if you want cell potential relation to K, you use this equation. If you want relationship of K with delta G, you use this relation. If you want delta G with the cell potential, you use this one. But if we summarize this is the relationship. Baka kasi pang multiple choice question to eh. A negative delta G will give you a value of K that's more than 1 and a cell potential that is positive. So usually if you have a cell potential that's positive, that's a voltaic cell. Now, if you have a delta G that's positive, your K is less than 1 because the backward reaction is favored and your cell potential is a negative, and usually this is your electrolytic cell. If your delta G is 0, your K is equals to 1, which means you're in equilibrium, and the cell potential will be equals to 0. You have a dead battery. So we end at least the discussion here. And I'm happy to accommodate any question or clarification that you may ask. Huwag na mahiya. Tanong.
Sir, tanong po ulit doon sa may doon sa may chlorine. Bakit hindi po siya nagamit kanina?
Alin yung?
Yung may chlorine po. Yung tatlo po silang
Okay.
BRI, tsaka chlorine.
Hmm.
Ito. Bakit hindi po ginamit po ulit yung chlorine?
Kasi kapag tinignan mo yung itong value nila, alin ang preferably mag-reduce?
Yung chlorine. Kasi
Okay?
mas mataas.
Kaya ang kaso, meron ka ba nito? Meron ka nito? Ano yung Cl form mo? Di ba CLI? Cl minus? So, hindi pwedeng mangyari na ito yung magre-reduce, ito yung mag-oxidize. First, wala ka nito. Ang form ng chlorine mo ay Cl minus. At kung ito yung masusunod, yung form ng Br mo ay ano? Br minus. And you have what? Br2. So, ang magiging reaction kapag ito yung nangyari, ito. Tingnan mo. Cl2 plus 2 electron producing 2Cl minus. And you have 2Br minus producing Br2 plus 2 electron. And what happened? Kapag inad mo, you produce ano yung available species mo? Or nasaan yung available species mo? Di ba dito? So, hindi siya pwede mangyari.
Ibig sabihin po, sir, pag nasa, parang titingnan po muna yung equation niya para malaman kung ano.
So, ito yung spontaneous na mangyayari. Why? Because of the reduction potential. Now, unfortunately, ang species na available ay nasaan? Nandito, di ba? So, ibig sabihin, hindi magre-react yung Br2 with Cl minus. If you want them to proceed, you need to have electricity applied to it or energy. And in that case, you're going to have a negative value. Now, why is it applicable with 107 and 0.53? Because 107 is higher than 0.53, right? So that means it will remain in this form. At sasabihin niya ito, mag-oxidize ka. And if say you oxidize, you're going to have this form na kung saan present yung species na yun. Na-clarify ba dyan?
Yes po, sir. Salamat.
Tanong, we still have time. Okay? And we will have a lot of time on Thursday. So I would suggest prepare questions especially related sa exam or sa quiz. Kasi yun naman yung role ko, at least tulungan kayo. Nangyayari kasi sa atin kumbaga itong relationship natin parang LDR, lockdown relationship, long distance relationship. So may advantage usually yung na-attend katulad nyo kaysa doon sa hindi na-attend. And I'm not sure if this type of thing will go on. ano yung latest balita nyo?